We want to use linear programming to find the minimum value of the objective function c equals 4x plus 3y subject to the given constraints. Notice how we have four inequalities here, so for our next step we want to find the solution to the system of inequalities, which will give us our feasible region. Once we find the feasible region, we'll find the coordinates of the vertices or coordinates of the corners of this region, and then we'll use those to find the minimum value of the objective function. So let's begin by graphing each inequality. Let's work our way from the bottom up. So if we want to graph the inequality y is greater than or equal to 0, we begin by graphing the line y equals 0, which is a horizontal line passing through 0 on the y-axis, which would actually be the x-axis here. And because the inequality is y is greater than or equal to 0, we want to shade above this line. Because there's so many shadings though, I'm going to use arrows to indicate which side of the line we're shading. So we're going to shade up here. Next we have x is greater than or equal to 0, so we'll begin by graphing the line x equals 0, which is a vertical line passing through 0 on the x-axis, which should actually be the y-axis here. Notice all the lines will be solid because each inequality does include equals. And we want to graph x is greater than or equal to 0, which means we'll shade to the right of this green line, which will indicate using arrows. So notice how we're only concerned about the first quadrant, because so far the first quadrant is the region that's shaded twice. Next we have the inequality 2x plus 3y is greater than or equal to 12. So we'll begin by graphing the line 2x plus 3y equals 12. And there's several ways to graph a line. We could solve this for y and put this in slope-to-intercept form, or the form y equals mx plus b. But because it's in standard form, let's graph this by finding the intercepts. So we'll make a table of values. In order to find the y-intercept, we'll set x equal to 0. In order to find the x-intercept, we'll set y equal to 0. So when x is 0, notice how we'd have the equation 3y equals 12. Dividing both sides by 3, we have y equals 4. So the y-intercept is positive 4. And now to find the x-intercept, we'll set y equal to 0. Notice if y is equal to 0, we'd have the equation 2x equals 12. Dividing both sides by 2, we have x equals 6. So the x-intercept is the point 6, 0. Let's go ahead and plot those 2 points. Here's the point 6, 0, and here's the point 0, 4. Now we'll sketch a solid line passing through these 2 points. To determine what side to shade, we'll select a test point. We can select any point not on the line. Let's go ahead and select the origin, or the point 0, 0. And we'll make the substitution into the inequality here. So notice if x is 0 and y is 0, we would have the inequality 0 is greater than or equal to 12. Well, this is false, and the test point is on this side of the line or below the line, and because that's false, we want to shade above the line. So we'd shade this half plane here. Notice so far this is the region shaded 3 times. We have one more inequality to graph. We have the inequality x plus y is greater than or equal to 5. So we'll graph the line x plus y equals 5. And again, let's go ahead and find the x and y intercepts. So we'll set x equal to 0, solve for y, set y equal to 0, and solve for x. Notice when x is 0, y is 5, and when y is 0, x is 5. So the x and y intercepts are both positive 5 here and here. Again, we could have just solved this for y. Notice that y would be equal to negative x plus 5, which means the line would have a y-intercept of positive 5, and the slope would be negative 1 over 1 and negative 1 over 1. Either way, this would be the line x plus y equals 5. And again, we'll select a test point to determine which half to shade. We'll go ahead and select the origin again with coordinates 0, 0. Looking at the inequality, when both x and y are 0, we have the inequality 0 is greater than or equal to 5, which is false. The test point is below the line, so once again we shade above, in this case the black line. So our goal here is to determine the region that's shaded 4 times, which represents the solution to our system of inequalities, which is our feasible region. So it can be a little tricky because there's so much shading, but if we're careful, we should be able to tell the feasible region has a border along the y-axis, then along the black line to here, then along the red line to here, and then along the x-axis here. So this region here is the feasible region. So for the next step, we want to determine the coordinates of the corners, or the coordinates of the vertices, and then we'll use those to find the minimum value of our objective function. I did graph this with some software to make it easier to read, so let's go ahead and use that instead. Notice how we have 3 vertices, one here, and one here. Notice how this region is unbounded, but we can still find the minimum value under these constraints using these 3 points. Notice how this point is the y-intercept of the line x plus y equals 5 and has coordinates 0, 5. This point is the x-intercept of 2x plus 3y equals 12, which has coordinates 6, 0. And notice how this point is the intersection of the line x plus y equals 5 and 2x plus 3y equals 12. We can tell from the graph it has coordinates 3, 2. But sometimes we can't find these points by analyzing the graph, so let's show how we could have found this point here algebraically. We'd have to find the intersection of the point x plus y equals 5 and the line 2x plus 3y equals 12. And there are several ways to solve this system. We could use elimination or substitution. Let's go ahead and use substitution this time. So we'll call this equation 1 and this equation 2. If we solve equation 1 for x, we could say that x equals 5 minus y. And now we perform substitution into equation 2, which would give us 2 times the quantity 5 minus y. There's our substitution, plus 3y equals 12. So now we'll distribute and then solve for y. So we have 10 minus 2y plus 3y equals 12. So combining like terms, that would be y. Subtracting 10 on both sides, we'd have y equals 2. Notice how this is the y coordinate, and then to find x, since x equals 5 minus y, 5 minus 2 would give us 3. And now for the last step, we'll substitute the coordinates of each of these points into our objective function to determine the minimum value of our objective function. Let's go ahead and do this on the next slide. Using the corner point or vertex 0, 5, we'll substitute 0 for x and 5 for y. Sometimes you'll see this written as c of 0, 5. So we would have 4 times 0 plus 3 times 5, which equals 15. Next, using the point 3, 2, we'd have c of 3, 2. So we'd have 4 times 3 plus 3 times 2. This would be 12 plus 6 or 18. And then finally, using the point 6, 0, we'd have c of 6, 0 equals 4 times 6 plus 3 times 0, which equals 24. So the smallest value of c is our minimum value, which we can see would be 15, and this occurs when x equals 0 and y equals 5. So we'll say the minimum of c equals 15 at 0, 5. I hope you found this helpful.